Algebra 1, Solving Linear Systems Algebraically, Exercise 3. The problem we're given is n equals 4m minus 1, 3m plus 2n equals 20. Two variables, but two equations. We can do this. If n equals blah blah blah, then every time I see n, I don't have to write n. I can write blah blah blah. So let's see what that looks like in math. 3m plus 2 times the quantity 4m minus 1 equals 20. Where did I get this? It was given. Where did I get this? It was given. Where did I get this? I substituted the value for n. Okay. So now I have 3m plus 2 times the quantity 4m minus 1 means I need to distribute my 2. 2 times 4m gives me 8m. 2 times negative 1 gives me negative 2 equals 20. 3m plus 8m gives me 11m minus 2 equals 20. So now I'm going to add 2 to each side. That gives me 11m. Negative 2 plus 2 adds to 0. We call that an additive inverse. 20 plus 2 equals 22. This is looking nice and tidy. I divide both sides by 11, and m equals 2. Am I done? I am not done. I have two variables, so I have to find the value for the second variable. Well, how am I going to do that? Let's see. N equals 4 times m minus 1. But I know the value of m, so n equals 4 times 2 minus 1. 4 times 2 is 8, minus 1, n equals 7. Now my answer could be an ordered pair, but if I don't have x and y, then who knows what was really supposed to come first. Traditionally, we go in alphabetical order, but I am perfectly happy to have an answer that looks like m equals 2, n equals 7. Would you like to see it in terms of elimination as well? Okay, let's do it in terms of elimination. N equals 4m minus 1. We also know that 3m plus 2n equals 20. Well, now here's the thing. I've got one variable on one side and one variable on the other side. But here I have both variables on the same side. So if I'm going to use elimination, I'm going to have to do something a little different. So I think what I am going to do, lots of ways to do this, I think what I am going to do is subtract n from each side. That will give me 0 equals 4m minus n minus 1. Okay. I'd prefer to have my equation look more like this one. So I'm going to add 1 to each side for good measure. That will give me 1 equals 4m minus n. So my first equation turns into 4m minus n equals 1. If I want to use elimination, I'm pretty close because I have a plus 2n here and a minus n here. But if I subtract this equation from this equation, I'm still left with an n, so that's not going to work. So here's what I should do next. For my second equation, I am going to multiply every term by 2. Two times 4m minus 2 times n equals 2. 8m minus 2n equals 2. Getting closer. We know that 3m plus 2n equals 20. Finally have something we can work with. 8m plus 3m, 11m. Negative 2n plus 2n is 0. 2 plus 20 is 22. 11m is 22. Divide both sides by 11. M equals 2. Am I done?
No.
N equals 4m minus 1. Wait, we did that up here. We had the same value for m. N is still equal to 7. I'm always thrilled when I get the same answer both ways.